In there, and if others join, we'll recap them on this. But hello and welcome to today's webinar on enhancing airport inspections with UAS or Uncrewed Aircraft Systems. Kind of the revolution, we like to say it. So for today, ultimately, we're going to cover the evolution of airport inspections, delve into the technology behind UAS, and explore real-world applications, including a case study from the Michigan Department of Transportation. Then what we'll do is we'll conclude with a look at future trends and have a live Q&A session. For housekeeping items, however, if you have questions during the presentation, just please write them into the questions box, and we're going to answer those at the end of the presentations in our Q&A section. Also, the presentation is available in the handouts box there in the GoToWebinar platform. So if you see handouts there in the checkbox, you can actually download the presentation. So with that, I am Paul Wheeler, and alongside me is Linn Smith. Together, we're going to guide you through the transformative impact of UAS or Uncrewed Aircraft Systems on airport operations. So I'm the Vice President of Aerial Innovation here at WSP. I've been passionate about UAS or remotely piloted aircraft since, I guess I'd say remotely piloted first since I was a kid, which really drove my passion to become a crewed and uncrewed pilot both. Back in 2010s when I really started testing the ways that UAS could assist in data collection to look at ways to improve safety, increase return on investment, as well as meet those data goals needed for kind of designing that next generation of transportation. And through that, it's been my pleasure to really work with many agencies, help them set up and grow their UAS programs, as well as with our pilots in WSP, who are also doing amazing things with UAS, where we're kind of changing the status quo in data collection and processing across industries. And it's my pleasure and honor also to have Linn Smith with us today to discuss the amazing things that he's doing in Michigan with UAS as well as advanced air mobility. And Linn Smith is the manager of Airspace and Emerging Aviation Systems at Michigan DOT, Office of Aeronautics. He has more than 33 years of experience working in transportation safety. Focus of his work for the past 24 years has been managing aviation planning, zoning, airspace-related projects, as well as initiatives. He's also led many system planning initiatives, including their Mission Aviation System Plan. He served also as administrator for Michigan Tall Structures Act, as well as staff specialist for airport zoning and airport planning. He also supervised MDOT's Aeronautics Planning Environmental Unit, and they provided critical services to local communities and airports on the planning, environmental, and land use issues as well. Today, he's really on the emerging aviation technology sector, where he's focusing on advanced air mobility issues, including multiple research projects, which one of them we're going to be talking about today, as well as others with emerging aviation. He's also a licensed pilot and has a degree in applied science and civil engineering technology. So with that, we're going to lead you on this exciting journey here. I'd like to kind of set with the background. Some of you are familiar with airports, others are not. But when I worked in the Division of Aeronautics there in the state of Utah, you really find out these airport inspections are a crucial element for global air travel. They serve multiple essential functions, really directly impacting that passenger safety, as well as worker safety, operational efficiency, and regulatory compliance. And ultimately, it kind of leads to that customer satisfaction if you're on these planes, just expect things to go well. And with that, the regular and really those thorough inspections ensure that really all aspects of airport operations, from the runway integrity to even the air traffic control systems and security protocols of the flights themselves, are really up to those highest standards. So we have the safest aviation system possible and one of the safest forms of transportation, really. It's not really helps in just preventing accidents and maintaining those smooth operations, but really ensures that everybody's adhering to the federal, international, and those local regulations. So you make sure you got that enhanced safety and efficiency that you need for that to be one of the safest forms of transportation. On the other side of that, though, however, when airport inspections aren't done right, the consequences can really be severe. You can have the pavement falling apart, or other oversight for even mechanical and structural failures, which can result in those delays and accidents, or even severe security breaches as well. Thinking of a past incident where neglected sky bridge or jet bridge had some issues, and ultimately it led to some injuries, raising some issues about airport safety protocols. So it's really important, and we're going to really get into how UAS can play a kind of a pivotal role into all this. And with that, I'm going to turn over to Linn to really talk about the evolution of airport inspections.
Thanks, Paul. I appreciate the time of everybody to hear what we got to say. The use cases that we're going to show you from the Michigan side really pinpoint what is going on with our airport inspections and how we've did the evolution between handheld instruments and maybe traditional survey equipment to using drones and how we collect the data to create a 3D model. Really, our focus on this type of inspection is the obstruction evaluation side of the different regulatory surfaces that you may encounter from a local governmental agency or maybe a state requirement for licensing of a facility or a federal regulatory agency such as the FAA. And then we also take a look at the design standards that might be a little bit different than what the federal regulation might be for off-airport obstructions, but for an airport that has commercial traffic or even general aviation traffic. So we're going to try to point out some of the limitations of using some of the older equipment, but then show you how much time and effort can be saved and efficiencies that can be found using the new data. Next slide, please. Thank you, Paul. So the previous method, like I said, was handheld collected or collected with handheld equipment, maybe an ABNY level, maybe a rangefinder. And some of the problem is the inspector, he or she would be out there and they'd be using the end of the runway as a reference and then looking out to make sure the approach was clear. And maybe they identified 3-4 trees that they could see, and then the airport sponsor or owner would go out and clear those trees, and then there would be 2 or 3 more behind that. And it was just a cycle that kept happening. Unless the airport conducted the very in-depth photogrammetry type survey that might cost tens of thousands of dollars, that was the best data. So we would get traditional data from the airport layout plan, which usually tends to have those more expensive in-depth surveys. But the new collection method for agencies inspecting airports or even airports inspecting themselves can be done with a very inexpensive drone in very, very quick amount of time. We're talking 30-40 minutes per approach. And then all that data can then be analyzed and then displayed in new methods, so we can relay that information back to somebody that might not really be in tune with the federal regulations or other regulatory agencies. Turn it back over to you, Paul.
Thanks, Linn. So as we're talking about UAS, we've got some different platforms that you use, traditionally rotorcraft or fixed wing, but I want to make it about the sensors on this. As we look at these UAS systems, the S there and the UAS, they're really equipped with these advanced sensors that are really transforming airport inspections, both efficiency and safety that we're seeing. So the primary sensor that most of these are using is an RGB camera, or red, green, and blue. If you don't know what that is, just your traditional camera. And these are ideal for really capturing those high resolution color images. And they're pivotal in those regular inspection tasks rather than monitoring surface conditions and detecting structural anomalies. For the most precise results, especially in mapping, an RGB camera with mechanical shutter is really preferred because it minimizes that image blur during high-speed captures, which ultimately leads to noise. As we look at other sensors here, in addition to those RGB cameras, we got the thermal cameras as well. They can detect temperature variations, which ultimately indicate electrical fault insulation issues or other hidden problems, even delaminations in pavement we use them for on bridges. And some of these things that's not visible to the naked eye. It makes them a really good tool as well to use. In addition to that, sometimes instead of having a passive sensor like your RGB camera, an active sensor like a LiDAR sensor, which uses laser light to measure those distances or create these 3D point clouds or maps of airport terrain and structures, can be useful for creating highly accurate 3D models that can be used for really maintaining geometric integrity of the runways and taxiways as well, or even obstacle assessment. You can do some of that with your RGB cameras through what's called structure for motion to create these point clouds as well. But camera being passive sensor, what you see is what you get, where LiDAR can actually penetrate down through vegetation and some other pieces with intensity. So another good tool in in your toolbox there. You also have zoom cameras too on these that can zoom even up to a mile on some of these. I've used them for traffic monitoring, other pieces. It gives you also the ability to do close-up inspections of hard-to-reach areas, really without the risk associated with sending personnel to some of these locations. Think about zooming in on the joints of a jet bridge, or even your lighting system along runways, or if you're trying to figure out what plane is out there, that's another reason you can use these. So really without compromising the safe operating area as well. And kind of together, all these sensors enable that comprehensive airport inspections that can really augment them and to help you out in this. Again, there's different price points on these, but you can start out relatively low price on these to get started, and then it can kind of go up from there. So as we talk about these sensors, I'm going to turn it back over to Linn to really talk about a case study here and to show you how they're using them.
Thanks, Paul. Yeah, and so for this case study, well, Paul, we actually started at the lowest price point with an RGB camera. So everything you're going to see, we designed a workflow around something that was sustainable and that true cost savings. And so we started with the lowest price point, and then we've worked our way up for different needs. So, but the case study I'm going to show you really concentrates on the obstruction evaluation and the licensing standards and design standards, regulatory design standards at a general aviation airport. This airport, you can see here on the right side of the slide, the red dots just represent the images that were taken. So that's every point that an image was taken. This flight lasted 12 minutes. So it's pretty incredible what we can do. So what we also did is we wanted our ground control point set, GCP set. And what that does is that increases our accuracy. And the whole flight, the whole process that we do, we make sure that we maintain Part 107 licensing, or Part 107 flight standards as well. So all our pilots are licensed FAA Part 107 pilots. Next slide, please. So this is the meat of it. Paul's going to run a little bit. So once we collect the photogrammetry, we do field verify it, and we make sure that we don't pick up our ground control points. If we need to refly the approach, if some of the imagery didn't come up, it was blurred, then we'll refly it right then and there. One of the things I do want to point out is most of the time our airports are open, so we have to be very conscious of following those Part 107 requirements and have a good safety plan in place. But what I'm showing you in the video is a quick representation of one of the protected surfaces. This is actually, if you're familiar with FAA Part 77, this is the FAA Part 77 surface for a runway, and you can quickly see how much vegetation is penetrating those surfaces. And then we're going to move over to the next slide, if you would, Paul. But the beauty I really wanted to show in this case study is the ability with one flight to collect all the data necessary to evaluate all surfaces, from a local regulatory agency like a state licensing standard to a federal regulatory agency like FAA's Part 77 for off-airport obstructions, and then into the regulatory agency's design for certain types of airports. So I return, FAA Advisory Circular 5313, the picture to the right is the surface for that threshold sighting surface that's outlined in that. Again, we can apply this to not just existing runway ends, but to future planned runway ends. So as a project moves forward into the planning and then the design process, we'll collect that data so we always have it. So it's a very powerful tool, very inexpensive. The pictures I showed you in the slide before showed a whole crew of people. We do these with typically with one operator, and that operator does set their own ground control point. So we only send one staff member to the field. If there's a case where the safety case requires another pilot for a visual observer, we'll do so. Next slide. So, one of the the most powerful side of this is before an airport sponsor or a manager would get an inspection report, and it's just a paper report. There might have been some still photos attached. What we can do now is we can export all of our findings into a KMZ file or even an ArcGIS file, and then share that with the airport sponsor and a manager, and then they can visually see where those obstructions are. So last year we did 29 airports. This year we've got scheduled 31. In the big kicker too is if you're doing traditional survey methods, you might do a full, I'll call it an 18B survey for those that are familiar with some of the FA survey requirements. It might be 6 months before you get that data back. Maybe you can expedite it and get it back within 3 months. We process all our data. Our goal is to process it within 2 weeks. Last year in those 29 airports, we did process, we did meet our goal, all but 2 airports. So we're getting that data back into the hands of the people that can take care of any of obstructions and get those mitigated quickly. Again, we set our priorities on the previous inspection date. So if it's been a while since they've been inspected or had a traditional 18B ground survey, we do that. We also prioritize by our state licensing categories for here for us in Michigan, but also whether or not the airport has any other federal government obligations as well. So we're working towards a rotating cycle for inspections every 3 years. And what that does is it really builds a case for how the tree growth is happening. So you can create a vegetation management plan pretty easily when you have our data, and we have multiple data. As we are, for some of our reports, we are flying them for the 3rd time. So we've been doing this a while. Next slide. So the challenge is always that regulatory hurdle, and then the safety concerns of flying airports when they're open. We will come across some privacy issues that we can alleviate because if you have a good neighbor policy and you let the neighbors know that you're going to be out there flying. So how we do it is we contact the airport management team and we let them follow their policy, and we assure everybody we are only collecting data for obstruction evaluation in this case. So that's how we work with the public perception side of that. I talked about the air traffic management. If you're flying different classes of airspace, specifically those with towered, it's going to typically be a waiver situation. And so I just warn you that if you're going to do those types of airports with this type of survey collection method, to make sure you coordinate those early and often, as I like to tell everybody. And the other side is the infrastructure needs. What do you need to fly these types of operations? For most of our airports, we're flying straight 107 without any need for additional infrastructure or sensors. We have been working on other cases though, where we're going to need sort of a more enhanced infrastructure to go beyond visual line of sight to get those waivers through the FAA. And Paul is actually going to touch on that a little bit. I'm going to turn it back over to you, Paul.
Oh,
Paul,
my
you're on
apologies.
mute, sorry. Yeah,
There we go.
thanks.
Yeah, so as we talk about future trends for airport inspections, that's where we're going now. Sorry about the mute thing. But as you see, UAS, there's a lot of different use cases you can use for these airport inspections, and I believe they're going to rapidly transform how we're doing this in the future. As you look at autonomous drone flights, thinking of geofencing these off for your runways so they're not impacting other operations, and you can do this safely with the different sensors that I showed before. Depending on the thermal or LiDAR, you can use those for detecting wildlife near runways that can pose those risks and be able to see them easily and make sure that you're not impacting your takeoff and landing operations or your ground operations with your aircraft. Also think about the infrastructure itself, building and energy assessments there with that thermal or helping airport facilities really reduce that energy consumption and improve that sustainability. You can also, again, like you've seen with the 3D maps there of obstructions, but think of having a digital twin of your airport, allow for virtual simulations and analysis that can really help you on your planning side and executing your construction projects and seeing how that phasing is working over time. to give you a better idea and precision with less interference with your daily operations, see where things are working well and where it may not be working well. Additionally, you can kind of get them into your airport management systems. Think of becoming an integral tool to really broaden out that airport surveillance or emergency response or counter UAS strategies. Have real-time data that enhances that situation awareness there for that. And as we kind of get into those pieces, even think about like the counter UAS side of this as well for when we're talking security. So even for drones, or if you've got perimeter problems or trespassers there, you can use these to secure those perimeters, monitor restricted areas without having to have those constant ground controls to make sure you got a really robust security posture as well, and preemptively identify and respond to any potential threats or unauthorized activities on the airport as well. As far as efficiency, you can quickly cover those large areas of the airport very fast, whether it's your runways, your parking lots, or even delivering that real-time feedback to your control centers, so you can have those faster response times. And ultimately, to help, like in emergencies, you get that bird-eye view with the thermal from the previous picture. You could kind of see where that stood, even though even in areas where your naked eye can't, with whether it's in fires, seeing the hot spots, or in gases, you can help find workers in there as well. And the counter UAS, these can use to help detect, track, and even neutralize some of those as well. So there's multiple pieces and ways that you can do this to really just augment the overall safety of your airport. And as we get into some other future technologies, I want to talk about the AI, or artificial intelligence, and even machine learning too as part of that. Another way that it's really revolutionizing data, not just in airports, but others, to where you can see kind of here on the automated things that we've done, the cracking detection. It's pretty laborious to do this by hand with a wheel. Let a computer do those things. That's not fun for you. Or even here you can see detecting missing rivets in your science structures or other things. You can do it with really precision, accuracy, and speed. So instead of having an inspector team go through every image, why not let this do it? Use it where it works well, use your workers where they work well, and augment the tools that you have. There's many ways that you can do it. Even like your buildings and lighting systems, you can put lighting on drones to illuminate construction projects, so you're not having the shadows and other areas that you might have that's impeding the light of the pilots coming into land. So there's many things that you can do. Ultimately, you train the data at the AI, and you can train it to anything you want. Even detecting things like low spots in your pavement with point clouds, where it's hard to do with traditional tools. You can even use it for that, and it can help identify those. So there's many different use cases. I could talk for hours on end with this, but I want to get through and make sure we address your questions as well. But with this, I want to really talk about kind of the next generation. What we're working with Michigan right now is on a communications mesh to really what they've built with digital short-range communication for automated connected vehicles. We look at the same thing and believe, why not make a mesh that can talk to all vehicles? And what I really believe that this can do is think about on the airport side, you could have your ground support equipment and drones that you're using here as well to seamlessly communicate with each other, even the airplanes themselves. So think of a vehicle to everything, or the CV to X, or the CV to infrastructure, CVI. You can use those to kind of make this integrated system of everything on there, so you know what's happening. So even the drones themselves, if they're in this mesh network, instead of using one to do this, you could have a swarm of those to enhance those inspections. They could be deployed to do a variety of tasks, whether it's even delivering parts directly to maintenance crews, or inspecting the aircraft themselves with precision, and just doing it rapidly in minutes rather than an hour. So there's quite a lot of things that you could do with this to really revolutionize those airport operations. Again, having that real-time intelligent decision-making piece, having those faster response times, and heightened security is kind of where it's all back. And but the key takeaways here, I just wanted to throw some of those out for it as well to kind of tie this up and get into questions. But as we look at these, there's many things you can do. Just having those 3D models, enhanced visualization I was talking about, really improve that life cycle and asset management piece. With the AI, you can do predictive analysis and really understand what's happening in real time, and even into the future with this accurate data that you have. Again, as we're having harder times getting our workforce hired as well. We can enhance those tools for our workforce, help them be more efficient, and really just future-proof our airports, especially as we're talking about adding new operations to them with advanced air mobility, and even just the growing aviation industry itself. It helps us future-proof those and really have scalable and good solutions, as I mentioned, with these meshes and other pieces to revolutionize this. And it's not without challenges. I don't want to limit that, but there's some challenges too, regulatory wise and just coordinating, but it's getting better and better all the time. And with that, I want to make sure we've got some time for some questions. We had some in the box as well. And I'd say that the first one is saying airports may be hesitant to use drones. How do you work with the airports to ease their concerns? And it's certainly, when you're talking about aircraft flying in, you need a safe environment. I think it's communication and letting them understand that you can geofence these areas so they cannot go into them. You could set up to where they land if they get close to that fence, or even turn the motors off completely, which I usually don't suggest because they can still fly, but you can keep them out of those. And really, once they see the efficiencies that you can use with these and the coordination between them, it helps ease some of those, but it's more about communication on that. Lynn, anything to add?
No, I agree. It's we contact airports a week in advance, and weather dependent. Obviously, we're flying in VFR conditions, but advanced communication is the key every time with a lot of what we do, but especially here.
Yeah. And the next question we got here, what sort of obstructions have you come across within the past and how did you manage it? And I don't know if you want to take that one, Lynn, and I
Oh,
can.
I got a great story there. So we have an airport that was traditionally inspected and actually had an 18B survey. So we had taken the drone out there. It was one of the first airports we did. And so the type of obstructions we usually find are trees, right? Vegetation that grows from the previous inspection or previous survey. And then we do it. We get out there with the drone and we catch everything that's come up since. Well, we found a billboard. It was actually an advertised billboard along a freeway. And how we do manage that, we will do an obstruction evaluation. We'll have the owner of a situation like that. If you find a fixed object, not vegetation, we'll have them go through the airspace process, and there might be a way to mitigate it. In this case, we mitigated it with an obstruction light, and we were able with that obstruction light not to affect the instrument approach procedure to the airport. Now, with the obstructions that you find that are vegetation, if the airport has an easement or maybe they have local zoning or airport zoning that they can use, it's another tool in the toolbox. They can go get that obstruction taken care of using the local methods to do that for abatement of hazards. And in some cases, the airport will go purchase an easement. And so this is a powerful, powerful tool for airports to identify what easements or what other controls they need to have. And I do want to point out, I missed it in the previous presentation, when we evaluate any of the surfaces, we always give 10 foot below too. Same flight, right? Same data collected, but we take the time, it doesn't take long to reanalyze it for setting the allowable surface 10 foot below so we can see what's coming on the vegetation side.
Yeah, fantastic. Yeah, and there's another question here. They're asking how these can be designed and used in parallel with drone detection and mitigation systems. So we're talking kind of counter UAS, and absolutely, there's many facets to that counter UAS, whether you've got radar that's detecting them or even other sensors. It could be audible sensors, or it could be ones for the communication itself to determine where the pilot and the aircraft is at. And really what these can be utilized is in when you have that detection system, using, again, the right tool for the job. Sometimes it might be a UAS that can go and catch that other drone before it poses the problem. It can also tie into your emergency systems. In the US, we have a 911 system, and we can alert the local law enforcement. So it kind of all works in concert together depending on the level of threat. If it's somebody that's a trespasser, then they can identify them, they could follow, track that person, and then again have your law enforcement know exactly where they're at. If they try and run or hide, you could find those defects in the fences. So there's many facets that I think you could do there as well. And I think we have time for one more question, but I also wanted to talk just housekeeping real quick. Again, if you join later on, this presentation is in the handout section there as well. And those questions that we didn't get to, we'll try and get to after the webinar. So let's see, for our next one, it says on the busier airports, we look at their traffic by hour and plan accordingly. Oh, actually, never mind. That's your response, Lynn. Let's see.
Yeah.
Do you have any specific information on pavement evaluation equipment and software?
So a lot of that, we have not did that here at MDOT, other than in test scenarios. We did have a couple just pilot projects, and it went really well. My understanding, working with some of the pavement management consultants, is we can use the same imagery. It is the same flight. It's just more extensive because we got to go the full length of all the pavements. Where typically we're just flying the approaches. But what we typically have to close the runway for that evaluation. But that being said, the imagery that we can collect about 90% of the data that needs to go into some of the calculator models to calculate the PCI. Some of the stresses we can't capture. We have to have boots on the ground to do that. But that is, I only talked to one person on that, so take that with a little bit of a grain of salt.
Yeah, thanks, Lynn. It looks like we got permission to go a few more minutes if you guys are okay with that. We'll end up at 35 after the hour here, so we can do a couple more questions. On this one, it's asking how quickly is technology changing and how often you have to update your standards and protocols. And I know for me personally, the UAS themselves are changing rapidly, and usually within 2 years you're seeing a complete replacement, even though you can still utilize those for many years past that. But just the sensors are getting better and other things. But as far as the standards, those are changing rapidly as things are being evolved. And I usually say review those as you need on an as needed basis throughout the year, but probably no less than a year. Every year, evaluate those and look at them and change so you can be finding out what's working well, what's not. But for our pilots themselves, we like to have that core competency level, then do some advanced training on top of that to make sure that they're doing things the proper way, things are working and coordinating there. How are you handling that, Lynn?
Yeah, same thing. We do a review of our operating procedure every annually, as well as all of our equipment. And it does lead into the last question about the fleet management software. We do monitor all the hours on all our aircraft. There's multiple software programs out there for sale that you can, or for purchase that you can implement. But we do look at our equipment annually, but then our procedures and methods. We do a lot of in the off season. I should have mentioned that we typically fly with full canopy leaves on trees. So here in Michigan, we have a good 3-4 months of the year where we have no leaves. So that's when we evaluate our not only our workflow, but of our equipment and then any of our standards, our flight standards, as well as our analysis standards.
Fantastic, thanks. And I think maybe for our last question, what was the most difficult challenge you had in a project for UAS? I know for me, specifically, we were doing an airport. It was in the US, it was a class Delta airport, so towered airport. And the weather, we had the AWAS out there reporting, but we had a wind gust that came up that over exceeded what one of our drones could handle, and it tumbled and fell. Luckily, we do our safety protocols. We didn't have any issues that way, but I'd say it shows the need for additional weather detection devices around the airport. Just to understand that these microclimates can cause a problem, and that's been a challenge. Some of the things with coordination of the airports, but really, again, communication helped that way. But let me leave that last second for you there, Lynn, and
Yeah, it's same
close out.
with us. So we flew a class Delta or actually a class Charlie airport the last couple of years, and it's the coordination side of that. It's the traffic management that kind of come up in one of the previous questions. Coordination with the tower, being a towered airport, it was key. We did have to go through a waiver process on that, and so early coordination there as well. So those are the biggest challenges that we've encountered in the first 5 years of our program.
Thanks, Lynn. I think we're out of time now, but again, we'll try to get to these questions. We'll try and email you. I think we have that contact information. And again, there is our contact information for Lynn and I. Please feel free to contact us directly if you got additional information. We're always happy to talk about this. And also, thank you for your participation in today's webinar. Hope you
Yeah,
enjoy the
thank
rest
you.
of your day.